Welcome back to 3 Inquisitive Kids. In this video, we will be learning about division of rational numbers. Chapter 2, Understanding and Learning the Rules of Division of Rational Numbers. Our course outline for this unit includes learning about rational numbers, the number line, and the absolute value. And we're also starting to do operations with rational numbers, like adding, subtracting, multiplication, and division. Our learning goals for today is to understand the relationship between division and multiplication, and master the division of rational numbers, and be able to perform mixed operations with multiplication and division. What is the reciprocal of the following numbers? The reciprocal of -5 is -1/5. The reciprocal of -9/8 is -8/9. The reciprocal of 7 is 1/7. 0 does not have a reciprocal, and the reciprocal of -1 is -1. And the reciprocal of -1 2/3 is -3/5. Do you still remember the definition of a reciprocal? We know that a reciprocal is a number times its reciprocal, which equals 1. You can see that 0 does not have a reciprocal because 0 times any number would equal 0, not 1. Here we have two sets of examples for you to calculate. 8 times 9 equals 72, -4 times 3 equals -12, 2 times -3 equals -6, -4 times -3 equals 12, 0 times -6 equals 0. So now what about the other way around? Now we're starting to do division. 72 divided by 9 equals 8. -12 divided by -4, based off of what we learned on the left side, we know it's 3. -6 divided by 2 equals -3. 12 divided by -4 equals -3. 0 divided by -6 is 0. So how do you determine the sign of the quotient, and how do you determine the absolute value of the quotient? I want you to be thinking about these two questions throughout the lesson. When we have 72 divided by 9, get 8, and -12 divided by -4 is 3. If both numbers have the same sign, the quotient will be positive. You can see that the dividend and the divisor here both have the same signs, so that's what it means when it says both numbers. We have -3 for both equations here. And if both numbers, the dividend and the divisor, have different signs, the quotient will be negative. And if you divide 0 by any non-zero number, you get 0. So does this answer some of the questions that we had in the previous slide? No, 0 can't be the divisor. Now I want you to compute these three expressions. The solution to the first problem is 5, -48, and -3. Think, how would you calculate this expression? For solution 1, we have -12 divided by the quotient of -1/12 and 100, which equals -12 divided by -1/1200, which gives us -14,400. And for solution 2, -1/12 divided by -12 divided by -100, which gives us 1/144 divided by -100, which gives us -1/14,400. You can see that in the first solution, they tried to group the -1/2 and the 100 together. And for the second solution, they try to swap the order of the terms around. The solution for the first problem is incorrect because in division you cannot just group terms together, you have to go from the left to the right. And solution 2 is also incorrect because you can't just swap the order. So the commutative and associative laws cannot be used for division. Compare the calculation results of the following groups. Here we have 1 divided by -2/5 and 1 times -5/2. For the second problem, we have 0.8 divided by negative 3/10 and 0.8 times negative 10 over 3. The third one is negative 1/4 divided by negative 1 over 60 and negative 1/4 times negative 60. Here, it's first 1 divided by a number, and then it's 1 times its reciprocal. This still equals negative 5/2. The second two expressions both equal negative 8 over 3, and the third two expressions both equal 15. Dividing by a number is equal to multiplying the number's reciprocal. Negative 2/5 and negative 5/2 are reciprocals, negative 3/10 and negative 10 over 3 are reciprocals, and negative 1 over 60 and negative 60 are also reciprocals. Dividing a number that is not equal to 0 is equal to multiplying the reciprocal of this number. A divided by b is the same thing as a times 1 over b. And remember, b cannot be 0 because 0 cannot be the denominator of a fraction. Compare and contrast. When we're subtracting with rational numbers, subtracting a number is the same thing as adding its additive inverse. So the subtraction is converted into addition, and the subtrahend becomes its additive inverse. When we're dividing with rational numbers, dividing a number is the same thing as multiplying its reciprocal. Division is being converted into multiplication, and the divisor becomes its reciprocal. Example 2. Calculate these two expressions. Solution 1 is negative 4, and solution 2 is 4/5. Here's some more practice. Calculate 24 divided by negative 6 equals negative 4. Negative 4 divided by 1/2 equals negative 8. 0 divided by any number just equals 0. And negative 7/8 divided by negative 4 over 7 equals 49 over 32. Example 3. Negative 125 and 5/7 divided by negative 5. And negative 2.5 divided by 5/8 times negative 1/4. For solution 1, we already know that the quotient is going to be positive, so we don't have to write down the negative signs. Now we're going to solve for the absolute value. This mixed number is the same thing as 125 plus 5 over 7. And we turn this divided by 5 into a times 1 over 5. So we can apply the distributive property of multiplication. So we're left with 25 and 1/7. For solution 2, we turn this all into multiplication and fraction form. So now we multiply to get 1. Class summary. If both numbers have the same sign, the quotient is positive. If both numbers have different signs, the quotient is negative. When we say both numbers, it means dividend and the divisor. And rule number 2 is dividing a number is the same thing as multiplying its reciprocal. So those are two things to keep in mind when you're dividing rational numbers. And also, 0 divided by any other number equals 0. Notice how here they wrote any other number. You can't divide a number by 0.